So for this video, we're going to look at the Unit 1 Review A, and then your job is to turn in the Unit 1 Review B by this Sunday. So this is what you should have gotten in the mail as a paper version of the course pack. And there's also the digital version available in JetNet that you can download and use. So I've been told that these page numbers are off. So hopefully you're able to find the correct page number. So let me scroll down to this Unit 1 review. According to my page numbering, it should be on page 110. I heard it was 9 pages off. So here's where the unit reviews are. We're going to work through this Unit 1 Review A together. Well, I'm going to create a video for you, and you all will turn in the Unit 1 Review B. Don't be afraid to email me questions or come to office hours. I would be happy to help you. So this first one is real basic. Express 45% as a decimal. Recall that to remove the percent symbol, you're dividing by 100, and that has the effect of moving the decimal 2 places to the left. You might want to put a 0 in front. Doesn't particularly matter in my opinion. So that's number 1. Real basic skill, but it's really important. We use that. We use percentages a lot in this course. All right, the second one, Jackson College had a cost of $152 per credit hour for the 2018-2019 school year. And then in the 2019-2020 school year, the new cost per hour was $160.25. So let's calculate the percent increase. Note that this is the old value we used. This is the new value. And percent increase is new minus old divided by old. We know it's going to be increase because the number is larger. We're going to get a positive number. So we'll do the 160.25 minus 152.80 divided by 152.80. Remember, these two values must always match. All right, let's type that in Desmos. So I'll split my screens here so we can see the two values, and we're going to do 160.25 minus 152.8. A common mistake here, if you're using your TI-84 calculator or whatever and you're trying to type this all at once and you hit divide, this is what your calculator does. It divides the number you're subtracting by. So what you need is parentheses so that you're dividing the entire numerator by 152.8. Note that value is approximately 0.04875. Notice I did not give you specific instructions on what to round to, so you get to round to whatever you want to. Now, we want the percent increase, so this is the decimal version of that percent. Remember, to convert it to a percent, we multiply by 100, which turns this into 4.88%. All right, so now we're to interpret our answer in context. So the context here is the cost per credit hour at Jackson College. I'm going to leave that off, but we should include that. Increased by 4.88% from the 18-19 school year to the 19-20 school year. All right, next one's a little annoying. Here we've got the table of the 2018 primary results for Governor of Michigan. This was way back when. This is obviously the Republican primary. And we are to calculate the percent that each percent votes that Bill Schuette got versus Brian Calley versus Patrick Colbeck versus Jim Hines, and then the number of degrees in a pie graph that this would represent. So I think the easiest way here is let's jump to Excel, and we'll let Excel do all this work for us. You could, of course, do this in Desmos if you wanted to, but I think Excel is a little bit faster. So I'm just going to type these numbers in. Hopefully I don't make any mistakes. Let me make this a little bigger for all of us. So here's the votes that each got. Now the things that we need is we need the total. So let's get the sum of this and we'll see how many people voted in this primary. There's that. Maybe I'll move it so it's not directly a part of it. And then we're going to divide each of these values by this. Now, if you want to have a fixed number, you put double dollar signs in there, and then it doesn't change this. And there we have it. Now, we want these to be rounded to this nearest percent. So I didn't show this to you all when you did in the project 1 videos, but I'll do it now. You can format these cells. So I'm right-clicking, and I'm clicking Format Cells, and we can turn this into a percentage automatically with 2 decimal places, if we so choose. And it converts it to that nicely for us. So I'll write that down over here. We got 50.23% for this one, and 25.18%, and 10.99%. Oh, did I forget someone? What's going on here? Oh, yes, this one was supposed to be 13 point. My bad. 13.10%, and then 10.99%. All right, if we want the degrees in a circle, recall that we take this percentage and multiply it times 360. Now it has to be done as a decimal. Check out what Desmos does for us. It does that automatically. It knows that we need, it knows how to calculate percents, let's say that. So let's round this to the nearest tenth of a degree, even though we haven't actually told you anything, any rounding values. So 182.6 degrees. Oops, I forgot to drag that. Notice I'm going to the bottom right corner, selecting that, holding and dragging that down, and we get all the rest of those values. And make sure you put your degree symbols on there, and that's it. We've done it. All right, so here is, so that was the Republican primary. Here was the Democratic primary results. There were 3 candidates, Gretchen Whitmore, Shri Tanandar, and Abdul El-Sayed. And notice I have told you how many people voted in the Democratic primary. Right here, that's this 112,608. So we want to know how many people actually voted for Gretchen, or Governor Whitmore, back in that primary. So we do 0.52 times 112,608 times the total. Now this is a great place for Desmos. Since we're just doing that single calculation, I think it's faster to type this in here in Desmos. And there we go. We get that this is equal to 58556.16. Now, these are people voting, so this number doesn't exist. So that means we know it's 58,556 votes, or, well, we'll say people. And then when we're asked how many degrees make up the sector, that should say for Shri Tanandar, we would do 0.18 times the 360. So again, in Desmos, 0.18 times 360, that would be the number of degrees. And this one, we'll leave it to the nearest tenth of a percent because that's totally possible. All right, here we're doing a little bit of unit analysis. So since I wrote these, this is actually me talking, but I made these numbers up. These aren't actually true, although they're probably not too far off, to be honest with you. So if I buy 15 eBay lots of Lego, weighing a total of 342 pounds for a total of $3,286 over a 1-year period, we're going to use divisional analysis to find the following. Cost per lot. Okay, so that's maybe this isn't dimensional analysis. This is more like a unit rate that we're doing here. So we're going to do 3,286. That's the cost. That's going to go on top, and this per means divide. So we'll put 15 on the bottom. Handy Desmos will get that for us. So 3,286 divided by 15. I'm paying approximately $219.07 per one lot. That's the cost per lot. All right, the cost per ounce. Ooh, so this one we're going to have to use a little bit of a dimensional analysis. So we're going to start with our cost, $3,286, and that is for 342 pounds. So we want this denominator to be in ounces. So we're going to use that 1 pound equals 16 ounces, and we'll put this pound on the numerator so that that cancels with these pounds and these 16 ounces in the denominator, and then we'll be left with cost per ounce. Not a measurement I actually use when I purchase Legos. I prefer to do cost per pound. So there we go. Hey, that's not bad, right? Rounded, this is 60 cents per ounce. Okay, finally the cost per day. Now notice I'm claiming that I did this purchase over a 1-year period. So we can do this in one quick swoop. We could just do, well, let's do the dimensional analysis way. We've got 3,286 for 1 year. So if we want to see what am I averaging per day that I'm spending, I just need to note that 1 year is 365 days. And here these years cancel, and we'd have cost per days. So 3,286 divided by 365. Oh, hey, that's not bad, right? $9 a day. Although my income is bi-monthly, so maybe I should look at how much is this per month. All right, and then we're going to go all the way down to the cost per minute. So we could take this rounded value here, this $9 per 1 day, and then convert that day into minutes, or we could start with the year and not round. I'll just go ahead and do the rounded value. So this is $9 per 1 day. We'll lose a little bit of accuracy, but not a big deal. So I want my conversion factor here to have the days on top, and I don't really know how many minutes are in a day yet. So I'm just going to use the 1 day is 24 hours, and then I'm going to put 1 hour here with the 60 minutes. And notice the days cancel, the hours cancel, and we're left with dollars over minutes. This is going to be a small amount, definitely, but that's okay. I mean, this is a totally made up problem. Okay, that looks like, boy, we better keep all of those values 0.00625 per minute. So that's like 0.6 of a cent per minute. Okay, number 6. So here we've got some fictional city that has 15 seats that they need to apportion to 7 districts. Oh, look, we're told that the standard divisor is 64,000, and we're going to use Hamilton's method to determine the number of seats. Now, this problem screams for Desmos. I mean, it's just, I'm sorry, not Desmos, but for Excel. So let me type these values into Excel. And we don't need that total. That was used to calculate the standard divisor. And once we have that total, we're kind of good to go. So remember, the standard quota is equal to the population of each district divided by the standard divisor. Now notice the population values are given in thousands, and I gave you this standard divisor not in thousands, actually written out. So when I do this division over here, I need to make it 64. Otherwise, we'll get crazy numbers. All right, here's our standard quotas. Here's why Excel is so awesome, right? I just drag that, and there's all our standard quotas. Now, the lower quota like we did in the project one, I'll use that same method. We do round down, and my number's here, and I want 0 digits. I mean, I know we could easily do this just by looking at it, but it's also nice to have a formula that does it quickly for us. So there I've rounded down. Note it's just eliminating the decimal, and then the upper quota, which you probably noticed it was never used. We round up. Again, here's our number and 0. So now this last one should be a 2, but whatever, or should be a 3. So we'll have to fix that one. Okay, so Hamilton's method, recall, says add up the lower quotas. So here I'm going to calculate the sum. So I'm just doing equal and sum, and I'm adding up all of these lower quotas. We need it to equal 15. Oops, it's not 15. So we have 4 seats to give, and the way we do that is by giving it to these fractional parts in descending order. So I'm going to sort these, and the top ribbon here is sort from largest to smallest, and I am going to expand the selection. No, we don't want to do that. So let me just, I'm going to copy this. So I'll do Control-C, Control-V. Oops, nope, I need to paste the values. And now I'm going to sort these from smallest to largest. Did I do that? Largest to smallest. Oh, it's only wants to do columns. Okay, never mind. We can just do this by IDing them. Note 0.95 is the largest. The next one will be 0.875, and then 0.67. So that's 1, 2, 3, and the final one is 1.59. So each of these gets 1 extra seat added to their lower quota. So I'm just going to do this, and I'm going to put a +1 in there, and then I'm going to go to the 2.87 and put a +1 in there, and then to the 0.67, put a +1 for that one, and we're almost there. The last one is this 0.59, put a +1 for that one, and that is the correct apportionment for this fictional city. So maybe we should write these numbers down over here. We'll do 2 decimals, 1.95, 1.39. One of the questions I like to put on the exam, actually one of my fellow instructors suggested I put it on there, is how was the standard quota calculated? Write a sentence describing how that was done. Remember, that's the total population of all the districts divided by the number of seats to be apportioned. So this is empty, and then here was our lower quotas: 2, 1, 3, 1, 1, 2, 2, and our upper quotas: 3, 2, 4, 2, 2, 3, 3, and then our final apportionment is what I have written over here in Excel. So 2. Wait. Oh boy. Okay. Hang on. This should have been a 1. So 2, 1, 4, 1, 2, 2, 3, and that adds up to 15. Okay. Let's move on to a bar graph. Number 7. So this following graph represents the percent of 177,120 North Carolina voters that voted for each of the 4 candidates, with 92% of all precincts reporting. This was a special election. You could see I used a lot of election things. It was handy. Okay, how many people voted for Dan Bishop? Oh, isn't this annoying? I didn't give you the numbers. Well, I did that on purpose because I wanted to see how good are you at estimating these values. So I'm going to say that that's slightly above 50%. Let's call that 0.51 or 51%. So we'll do that times the amount of reported voters. And this will be our estimate of it. It's probably wrong, but that's okay. It's close, right? So 0.51 times 177,120, that gets us 90,331.2. Now again, this is not possible, so the correct answer is 90,331 people or votes. So how about how many people voted for Dan McCready? Well, looking at this, we're below the line, and it's a little further below than, in my opinion, than what it was above. So let's call that 0.48. All right, so I'm just going to take the number I just typed in and change it to a 0.48, and then that gives us 85,107.6. I should say that's the exact value, which really, again, you can't have 0.6 of a voter, so we round that up for that many people. Okay, what percent of the voters voted for Jeff Scott and Alan Smith? So the two of them together. All right, it looks like 0. But if we use our estimates from above, which we should, because we've already claimed that those are the values, we get, 99%. So that means 1% voted for those two candidates. All right, that's the end of our Unit 1 review. So Unit 2, this just as a comment, if we weren't face-to-face, this was the exam I wrote for students to take. So I'm giving you this exam as like a take-home. Go to the tutoring at CSS if you want help. They have fantastic tutors there. Come to my officers, ask me, email me, ask your professor if they've assigned this to work through these sets of problems. And I'm for me, those in my class, I'm grading this for correctness.